Hello friends, today we will be starting a very new subject which is higher engineering mathematics, and myself being from an engineering background which is a non-mathematical background, which is I don't have any formal training in mathematics, but still I had a lot of fun in learning this particular subject and many other things in it. So I found it very interesting, and let's see how learning these things can make your life much more interesting, and it can make things very easy. So as you see, I've also uploaded some videos on discrete mathematics, but this would be something that is completely different, and it involves a lot of new concepts, a lot of difficult concepts from higher engineering mathematics. And some of the curriculums have also called this subject as M3 as well, because it usually comes in your second years. So sometimes the subject is also called as M3. But anyways, basically it is just simple higher engineering mathematics, and the two textbooks that I will be using for this is one of them is Ramana, and the other one is Dr. B.S. Garewal. So these textbooks, they are pretty big. They might seem intimidating, but that consists of the entire mathematics in engineering. We're not concerned with the entire mathematics of engineering. We are concerned with smaller parts of it. Smaller parts of it that contain ODE, that contain linear differential equations, that contains LDE, that contains ODE, or ordinary differential equations, that contains also I'm also planning on having a bit of PD, which is partial differential equation. Then we will also definitely be seeing Leibniz equation. We'll also be seeing Cauchy and Legenders. So all these things we will definitely be seeing, and what these are, what the concepts mean behind them, how can you study them, and all these things we will definitely be seeing behind them. So slightly related to your syllabus, and slightly may not be related very closely to your syllabus, but see, this is how things always are, and I always suggest all my students and all my friends to kindly read something that is not a part of your syllabus. That is what will really have a lot of invigorating of interest in the subject. So always have this kind of an approach in your life. Then usually whenever in this particular topic, we will be starting with differential equations. So under higher engineering mathematics, we will be starting with differential equations. So even I myself have been studying this particular subject from a pretty long time, but still not from a very long time. So there's definitely some things that I'm still trying to learn. There's definitely some things that I could improve. So even I am learning this subject every day, every moment. It's a very vast kind of a subject. People spend their whole lives in this, and I've just tapped into a few interesting things which I found interesting, and also they're relevant to your syllabus. So it kind of helps you out. Anyways, we will be starting with the differential equations over here. So the very first thing that comes to your minds whenever you hear the word differential equation is students get very frightened. They get very confused, and they're very reluctant to learn about differential equations. Please don't be reluctant. These concepts are not very difficult if you understand how things work. Never try to mug up things. I always tell all my students, never try to mug up things, especially in subjects like this. You can of course see how formulas are related to each other, but never try to mug up things. Just try to get to the basic concept of how things work. That will really make your life easy. Never try to mug up these things. Anyways, as soon as students usually hear the words of differential equation, they get slightly confused and slightly frightened. So there's nothing to be frightened of any sort. If you just know how things work, you can definitely score very good marks in this topic as well. So moving ahead, what exactly is a differential equation in very simple terms? In very simple terms, a differential equation is an equation that contains some terms that are derivatives of a variable. Okay, so what is a differential equation? It is an simple equation. So it is an equation that simply contains the derivatives, of a variable. Simple, very easy. So what kind of an example that I could give for this? A differential equation is an equation that contains derivatives of a variable. Very easy. So one such kind of an example that I could give is simply y plus dy by dx plus anything sin x equal to 0. Now if you see in this equation, and one more equation that we could just simply compare is something like y plus y square plus sin x equal to 0. So just simply try to compare both of these equations. In both of these equations, one very clear differentiation that you can see in both of them is that there is this particular term. So what exactly is this term? This itself is the derivative. It is the derivative of what? It is the derivative of this particular variable, which is y. Okay, now that is what makes this a differential equation and this not a differential equation, because if you see in this equation there is no derivative of any variable, there is no d by dx, there is no d by dx. Since this d by dx term is missing, that makes it a normal equation, while on the other side in this equation, as you see, you have a d by dx term present over here, which simply makes it a differential equation. That is enough, that is just enough. So by the help of that you can very easily differentiate whether some equation is a differential one or it is not a differential one. Then moving ahead, as soon as you guys see things like this, as soon as you guys see things like differential equations, usually students are very reluctant, and students are always trying to ask me a question that where do we use this, how is this important in our lives? So see, the applications of differential equations are very large. You have no idea how important this is. Anyways, basically what is a differential equation is when you have a single variable. Okay, now see, try to understand this. When you have a single variable, or okay, to make it more simple, instead of making a variable, let's make it an entity. Okay, so let's say you have a single entity. Fine. So now when you have this single entity, is it possible for you to study this entity as a whole at all the times? No, it is not always possible to study this entity as a whole all the time. So what is your solution for that? A solution for that is you could simply break this single entity down into smaller sub entities, and once you are able to understand these smaller boxes of entities, then you can definitely understand the main box of this entity. For a simple example, let's say that you have to reach your college at 9 o'clock. Okay, so what is your main motive over here? To reach your college at 9 a.m. Fine. So now as soon as you wake up at, let's say, 8:45 a.m., are you ready to go to the college? No. This single entity, it looks as one, but it contains of many smaller sub entities. Like for example, the first particular entity over here would be to wake up at 7 a.m., and then the next entity would be over here to probably work out a little bit, so maybe work out at 8 a.m., and then the next entity over here would be maybe take a bath at 8:30 a.m., and finally the last entity over here would be to leave the house at 8:45 a.m. So tell me, in from your real life example, what do you do whenever you have to reach your college at 9 o'clock? What do? Do you just wake up at 8:45 and leave to the college? No, you definitely perform all these tasks. So what did you do over here? You had a single entity, you split that entity into smaller sub entities, and if you are able to perform these smaller entities properly, it automatically means that you will be able to perform the larger entity also properly. By the exact same virtue, we need to study differential equations where we have a single entity, we divide that entity into smaller parts. This exact process of division itself is called as d by dx, or differentiation, where we differentiate things, we create smaller partitions of this thing. So similarly, I could give you many more real life examples. One more example would be, let's say that there are guests coming at your house. Okay, so let's say there are guests coming at your house and you have to cook food for some 1,000 people. Okay, let's say you have to cook food for some 1,000 people. So what do you do on the day of the event? Do you directly cook the entire food for 1,000 people and serve it to everyone? No. Why not? Because you're not used to it, you don't know how things will react. That is why what you do over here is you will split this task into smaller subtasks. Like for example, you'll have entrees on one day, you'll prepare for entrees on one day, and then you'll prepare for the main course on the second day, and then you will prepare a dessert on the next day. And that, will you prepare this for 1,000 people? No, this is just a test batch, it is just a test phase. So what you will ideally do is you will prepare an entree for, let's say, 3 people, and then you will, on the next day, you will prepare a main course for 3 people, and then maybe you will prepare dessert for 5 people. Now what you have actually done over here is you have identified the exact parameters in your recipe. So once you have understood how much salt you need to put in, how much pepper you need to put in, how much other ingredients you need to put in for preparing the food for 3 people, for preparing the food for 5 people, then what you need to do on the main day, on the day over here, what you need to do is you just need to multiply these ingredients over here. You just need to multiply these ingredients over here, and then what will happen? Your food for these 1,000 people will already be ready, and that will definitely be very experimented kind of an scenario, because you've already done all these, you've already tested all the parameters out for smaller sample size. This is ideally an sample size. So in this way, if you just closely try to analyze the actions that you guys do, you are always surrounded by differential equations. Even when you start reading a book of, let's say, 100 pages, do you read the 100 pages at once? No, you read it page by page. Why do you read it page by page? Because you will understand it better. In the exact same manner, we need to have differential equations so that you can divide, you can split a larger entity into smaller entities, and then we will study those smaller entities. Now leave apart these real life examples. These are important for you to just arise your interest into the subject. Now some more complicated and more technical examples that we need to know is, one very large application of differential equations is in signal processing. It is in signal processing. So what exactly is there in this signal processing is that, let's say you have a signal. Okay, let's say you have a signal that has got many parameters inside it. So what kind of parameters and what are parameters? So to quickly understand this is a whole different subject, guys. So in order to quickly understand this, imagine that you're talking to your friend on a video call. Okay, on a video call. So what kind of signals are you receiving from your phone? You're receiving two kinds of signals. You're receiving an audio signal from the speaker, and you're obviously receiving a video signal on your screen. So what kind of a signal it is? Is it a normal signal? No, it is a mixed signal because it has got two parameters inside it. So let's just compare what these things mean. Okay, so I am now comparing these two kinds of signals. This is the first signal, which is a normal audio call. This is a normal audio call. Similarly, on the other side, I will have a WhatsApp or any kind of a video call. Okay, now in an audio call, what kind of parameters are present? There's only one parameter, and that one parameter is voice. That one parameter is voice. Okay. Similarly, in case of a video call, there are two parameters present. Now, not necessarily that the two parameters will look the same. So, in order to make things slightly more interesting, let's say you have got a video call. Inside that video call, this signal is of a video. Okay. Then similarly, as there's in a video call, there's video as well as audio. Let us denote this dotted line by an audio signal. So this is an audio signal. So now you can understand the difference between both of these signals. I hope yes. In the first signal there's only one parameter. In this signal there are two parameters. So now before diving into the technical aspects of these things, let's see how your body behaves. In this case, whenever you're using a single signal, there's only audio inside it. Then do your eyes need to focus on something? No. The answer is no. So there's only one parameter over here, and in order to understand this one parameter, you also need only one sensory organ. Similarly, in case of a video call, just see how many parameters are present over here. There are two parameters present over here, and for you to understand a video call better, do you need two sensory organs? Yes. Since there are two parameters involved over here, video will be sensed by your eyes and audio will be sensed by your ears. In the exact same manner, if you convert this real life example into a technical problem, then what happens? In a single parameter signal, you can simply understand that by the help of a single speaker and a microphone. Similarly, in a video call, you need two parameters. Video will be understood by a screen, and audio will be understood by a speaker. So now see where the problem arises. When you have actually used a video call, then is the video and audio always in sync? No. The answer is no. Then your video chat application like WhatsApp or Skype, what preference does that provide? It always gives preference to audio. Even if video is grainy, it will always try to give better audio reception, because you must be able to hear something. Even if you're not able to see everything very clearly, it is fine, but you must be able to hear something. So now you see what is happening over here. If both of these, now what I'm trying to tell you is these two kinds of parameters inside the signal, they are processed separately. Now what is the proof of this separate processing? The proof of this separate processing is that when your signal becomes low, then your chat application automatically tries to give more importance to audio as compared to video. That is why these are processed separately. If they would have processed at once together, then what would happen? When the channel becomes low, when your speed becomes less, then both audio and video must be stopped. Does that happen? No, that does not happen. That itself means that the two parameters are processed separately. Now this is where differential equation comes into picture. How do you separate a signal that has got more parameters? How do you separate a signal that has got more than one parameters? The answer is again differential equation. That is how your chat application understands which signal is weak and how should I manage it. So how does it manage it? It tries to make the video grainy in order to give you better audio performance. Then even if that does not solve the problem, then what happens? It will stop the video. It will display a message saying that I cannot process this kind of an signal, so please just listen to audio for some time unless your signal becomes better. So this is where you can use differential equations in signal processing. To be more specific, there's a lot of transforms, Fourier transforms over here, by the help of which we can perform signal processing. But ultimately you're going to separate a single signal which has got more than one parameters by the help of differential equations. So that was some of the applications. Then usually one more thing that I would like to mention in the beginning itself is that you guys have already studied algebra. You guys had already studied algebra. So, since you've already studied algebra, why to study calculus again? This also is a interesting point. What is the difference between algebra and calculus? So one simple thing over here is algebra is always used to study scalar quantities. These are always scalar quantities. So what is a scalar quantity? Something that has only a magnitude and no direction. For example, you could have you could have you could have mass over here, which has got only magnitude and no direction. You in the on the contrary, in calculus we always study such parameters which are not scalar, which means you will always be studying stuff in curves. Over here you will definitely have all the vector quantities. What is a vector quantity? Something that has got both magnitude and direction. So these things that we will be definitely studying in calculus. What else? Different fields make use of differential equations in their own particular way. Management graduates make use of it to predict better values. Doctors make use of it to predict what a strand of your DNA should be modified or should be repaired. One more aspect over here could be that you guys have all studied force. So what is the very basic formula for force? Force is the product of mass and acceleration. Correct? Force is the product of mass and acceleration. So whenever you're studying this formula with respect to algebra, it could be very simply written as force is equal to mass into acceleration. While on its contrary, if you're trying to study the same by the help of calculus, then the formula would slightly change. It would become force is equal to mass into what is acceleration? What is acceleration? It is the change in. It is the change in what? It is the change in distance with respect to. It is the change in distance with respect to time. It is the change in distance with respect to time. So how can you convert this into calculus terms? It is the difference in distance upon time. So stuff like this. So by the help of these things, you can definitely understand how a simple similar formula can be converted into a calculus formula. So I hope that much is enough for the first lecture. In the next topic, we will definitely dive into what is the general equation, why to study the general equation, and the first problem also we will be definitely studying.